Let's launch a new tab in Chrome and navigate to notebooklm.google.com. Once inside the welcome screen, feel free to explore the example notebooks such as the invention of the light bulb. Once inside the notebook, you will notice two sections. On the left, there are the sources, and on the right, the centerpiece is the chat and the guide. The notebook guide is a very helpful section that will help us create FAQs, study guides, table of contents, timeline, briefing documents. And if you click view chat, you will go back to the chat window. We'll close this for now. Okay, and here is our notes. We can take notes based on the chat descriptions. But before we start, let's take a look at our sources. There are 4 sources listed here. As you can see, the first one is a link from Wikipedia. The cool thing about it is that you can add multiple sources. They can be a web page, they can be a YouTube link, they can be a document you can upload, and it supports multiple types of documents. But once there, you can preview this document and select keywords to tag the conversation. So this first document, for example, key topics are commercialization, early research, incandescent bulb history, energy efficiency, and so on and so forth. So you can click these and this would launch a chat conversation. Let's take a look at the second one. This is a Wikipedia link about Joseph Swan, and it's their biography. It's tagged again with a number of keywords here. So let's close that. Let's look at Thomas Edison's biography. Again, this comes from Wikipedia. And here you can see the entire page being parsed and being brought on as a source for this notebook. So let's kickstart this with just the electric light, for example. As you can see, the electric light discussion is launched in the chat, and you can close this. So currently, it's using all 4 sources because they're checked. Here you can filter sources per question. So if you have a question specifically on one source, as we're going to see later, you can filter that by unchecking some of the sources. And here is the main screen, the history and development of electric light. This is the answer to the question, basically, which was discuss electric light based on these documents. So what's cool is that for each paragraph, there are citations. So you can go and hover over them and it will explain from which document it's pulling this information. And if you click on it, it will actually put you to that document and highlight the section that talks about that. And you can continue doing it like this and go to the relevant sections of the document. So that's really, really good. The other thing that is cool is that it will start suggesting questions here for you. So this will spark ideas. It would be a mini brainstorm. So let's click on this next question. Let's close this pane and see what is the first building in the world to be lit entirely by electricity? Here is the building. And it's very nicely highlighted or in boldface so it can be noticed. And that's a really, really good question. Let's go in and type something else. What other inventions did Edison work on? And let's see what the tool does. The response is here, and we can see it's rather long, detailed response. And it talks about Edison's diverse inventions beyond the light bulb. Some of these are probably unknown to most of the people because he's mostly known for the light bulb. And let's say that we like one of these answers. Then we can add it as a note to our board. Actually, for this particular notebook, it's not enabled, but I'll show you later in our actual use case note. Okay. So back to the notebook guide. Again, some of these sections are disabled because it's an example notebook. But once you have your own, we'll take a look how to create an FAQ, study guide, table of contents, and so on and so forth. Cool. So yeah, this is just a quick walkthrough of the example notebook. Now we can go back to the interface and start our own. Click New Notebook, and immediately NotebookLM will display the screen to upload or link resources. As you can see, there are a number of types of resources that are supported, but for this tutorial, we're going to use 3 resources. We're going to use a use case that I prepared, we're going to use a YouTube video, and we're going to use a web page. For the use case, I use ChatGPT and ask the following prompt. Create a very long, very detailed use case for a core banking system originally built in the 80s using COBOL and mainframe computers. Add business rules for calculating interest rates, debit amounts, account creation, closing transfers, and fees. ChatGPT created a very detailed use case, which I saved as a markdown file into my Visual Studio. So here is the use case document. It does have a number of business rules it includes exceptions, it includes alternative flows, and most of all, it is very specific on numbers, interest rates, so it's ideal to give it a test drive inside NotebookLM. Once in NotebookLM, let's upload our use case. Choose File and choose your Markdown use case. And by the way, it can be a Markdown, it can be a text file, it could be a number of formats, it could be a PDF file. One thing that NotebookLM does not support is CSV or Excel files, which I'll show you how to find a workaround in the next video. By the way, let's rename our notebook here and call it Core Banking System. Okay, so with that, we already see that our document was processed and we have some suggestions already. But let's add our other resources as well. Let's click the plus button and here you'll see the YouTube link. Let's go to YouTube. This is a video I found earlier about core banking systems and just explain some of the features of modern core banking systems. So I'm just going to copy the link, go back to my notebook, click on the YouTube link and paste it here and insert it as a resource. As you can see, it just got added. For the third resource, I just found this through Google and it's an article. It's just a web page on modern core banking systems and some of the problems of the legacy systems. So I'll copy this URL and bring it over here and click add an extra resource. And here's the website. I'll just paste this link. Now, in your case, this could be a use case document from your local Confluence server or a Jira ticket or any other web resource that you may have internally. And here you can add up to 50 of these sources. As you can see, all three are currently processed and already have some suggestions to start asking questions. But before we start the questioning, what I like to do is creating the briefing doc. So let's click this and now the document is being generated. And now we have our briefing doc generated. Let's take a quick look. So the main themes are listed, the challenges of legacy core banking systems, the need for modernization, there's important ideas and facts, there's citations from what sources they come, there's an embracing progressive modernization, and there's the benefits of modernization. There are some codes and there are next steps. So this is really good. It's automatically added as a note to our system. Let's explore the other options as well. We have a study guide, which does not apply to this type of a document. We have a timeline, which also does not apply. Table of contents is something you can create as well, and FAQ as well. For this document, we're just going to start with some suggested questions. So let's look at the first question. What are the primary challenges and limitations of using a COBOL-based core banking system on a mainframe platform? So this is one of the questions. And one thing you may notice that it says 3 sources here because all of our sources are currently selected. And that means that when I ask a question or select one of the questions, information from all 3 sources will be used to answer that question. This is very useful if you want to limit it to a single document. For instance, if you're looking for a business rule, you may just want to select the use case. And here we have our answer: challenges and limitations of COBOL-based core banking systems on mainframes. Again, outdated architectures, integration difficulties. One thing you'll notice here is that there are citations. Again, if you hover over them, you'll see the source and you'll see a quick description of the text itself. You can also click it and it will show you the document and highlight the particular section where this came from. This came from the web page that I added, and lack of agility and flexibility and so on and so forth. Okay, let's close this and let's go to what are the key features and functionalities of a core banking system. Again, a very detailed description of the features of a core banking system, including customer information, KYC, account management, transaction processing, fund transfers, so on and so forth. This is very, very extensive. Now, one thing that we can do here, of course, is we can save this to note. If there is an answer that is particularly interesting, we can save that to the note. And here, we now start building a collection of notes that are particularly interesting for our case. You can also add your own handwritten notes. So for example, here, you can write your own notes as well, and you can close this. So that's great. And now let's ask a series of questions specifically on the business rules. So one thing I'll do is I will unselect all of these documents and only select the use case document. With this selected, I can start asking a series of questions. What are the key features and functionalities of a core banking system? Now we're using only our use case document. And based on this information, in our use case, we have a number of features: account management, transaction processing, interest rate calculation, fees and charges, security and compliance. That sounds really good. What are the problems with current banking systems? Again, a very detailed answer with multiple points and citations. So we can take a look at the sources and understand where this information is coming from. Very good. You can close this. And by the way, at the same time, we can close this, open this document and see the key topics in it and start exploring those topics. For example, discuss account operations. And here's the answer to our question. Account operations in a legacy core banking system. Account creation and closure, deposits and withdrawals, fund transfers. All of these operations are listed from our use case. What is a large transaction? Now it will define large transaction based on the business rules from the use case. And in this case, the sources mention large transactions in the regulatory holds, and it mentions the number 10,000 can trigger such holds. So that's really good. It's citing business rules. What happens if the system crashes? Very detailed answer based on the use case, and this one shows us the crash consequences in a legacy core banking system. We like this and would like to add it to our notes. What are the conditions for a customer to request a fee waiver? Here are the conditions for a fee waiver request in a legacy core banking system. Here are the rules. They're clearly explained. Again, in this case, our use case is a little over 10 pages of documentation, but imagine a system where you have hundreds or even thousands of pages of documentation. This is great help to summarize that business rule. How does a legacy core banking system handle account closures with non-zero balances? And the answer is the balance verification and prompting, customer options, and so on and so forth. It provides insights and implications. It's a very, very detailed question. You will also notice that as we type our questions and saving the answers to our notes, NotebookLM is also suggesting other questions. So sometimes it's good to explore beyond your own questions to what is possible. So for in this case, minimum balance requirements for savings and checking accounts, question that I didn't think of, but the tool suggested. The other one is, what are the business rules for interest calculation on savings accounts? Imagine yourself writing a method for interest calculation. We're asking for the business rules coming from this, let's say, potentially very complicated use case document. And as you can see, very detailed business rules with tiers and rates, very detailed business rules. Let's explore adding a test to this. How would you test this use case? And let's see what the tool comes up with. So as we can see, it's a very comprehensive test strategy document almost, because it explains the functional testing part, and here are the features. It explains the alternative flow and exception testing, and it explains the non-functional testing, especially performance, security, and compliance. That is a really, really good level of detail. What is the part of the system that is hardest to maintain? Maintaining a legacy core banking system, it provides insights into what parts are the most complicated and brittle. That's really good. Now let's ask another question about testing the system. Suggested testing methodology to test the system. We have a great multifaceted testing approach for leveraging existing documentation, legacy system challenges, combined testing methodologies. It's a potentially great answer. For the functional testing items in the testing methodology, can you create a detailed test case? Okay, and here we go. We have a detailed test case. I particularly asked to do a functional testing, and it only picked up one use case, which is fine. This can be expanded to other use cases in the system. Of course, core banking comes with hundreds of use cases, but it picked the account creation. It gave it an ID. It has a name, objective, customer data, steps, expected results, preconditions, postconditions, and additional notes. So this looks really, really detailed. Next question. How should operations monitor a system such as this? Now we're moving from testing to ops. And we have our answer. Monitoring a legacy core banking system, a holistic approach. And here it gives us step-by-step monitoring, business process monitoring, compliance monitoring, tools and techniques, and a pretty detailed explanation just based on the use case document provided. For this next question, we're going to enable all sources. What are the most significant challenges and potential risks associated with maintaining a modernizing a legacy core banking system? Here are some significant challenges and potential risks associated with maintaining modernizing. System complexity, technical debt, integration challenges, security risks with citations, skill gaps and knowledge loss because of COBOL, high operational costs, resistance to change, disruption to business operation, vendor dependence. So very, very astute observations and notes here. How does the system handle edge cases, exceptions, and alternative flows to ensure operational resilience, accuracy, and regulatory compliance? Handling edge cases, exceptions, and alternate flows in a legacy core banking system. Very itemized, as well as citations I provided. So this is useful information when you start developing the actual code. Let's save this to the note as well. And let's go back to view the chat and save a few others to the notes as well, so that we build our notes. And we have a number of notes here. That's really, really good. Let's ask our last question here. Can you convert my notes into a PowerPoint? Okay. In this case, the tool tells us that it cannot do this. And you'll face this with some of the questions. You will ask to do something, and then the answer will be, I can't do that. Currently, it will not create a PowerPoint for you, but it will give you a bulleted list. It can give you a bulleted list of items for your PowerPoint slides. During testing of the system, in fact, I asked this question and it gave me 6 slides with a number of bullet points. So it really depends on the context and the questions. And sometimes you get a good answer. It's good to try, and it's good to try to ask the question in a number of different ways until you perfect your way of extracting information. Now, you can close the chat. You can go back to your notes and review the notes. You can organize these notes. You can come back and update your handwritten note. And as soon as you do that, it will go to the top of the notes. You can delete, obviously, notes. Some of the view features of the notes are somewhat limited in this UI, and those are some of the items that are room for improvement. For example, you can't maximize this note, or you can't export it somewhere. You cannot reorder these notes yet. You cannot drag and drop and reorder them. You cannot print them. You cannot put this into, let's say, a storybook of sorts. But there's one interesting feature of all this that I'd like to show you as the end feature. Go back to Notebook Guide, and here there's this audio overview, and this generates a podcast based on your notes. Click the generate button, and it takes a few minutes to generate, but what I'm going to do is I'm going to download this podcast and add it to the end of this video. It will be somewhere between 6 and 10 minutes. So if you're curious to listen to 2 people discussing the core banking system, please watch until the end. Let me know what your thoughts are on the podcast.
Ever feel like we're living in a sci-fi movie?
It's true.
We toss around terms like fintech, and tap our phones to pay for like coffee, but how often do we actually like think about the systems that are, making all that happen?
Right.
Today's deep dive is all about pulling back the curtain on something that I think we all use every day, but we really rarely examine core banking systems.
A bit like a magic trick, isn't it?
Yeah.
The intricate workings are hidden from view.
Right.
So the user experience feels effortless.
We're talking the nuts and bolts behind every deposit, every loan, every online transaction. And this isn't just about what we see as customers, right?
Exactly.
One of the sources that you sent over a YouTube video on this topic describes a CBS as the central nervous system of a bank. And I gotta say, that's a pretty apt analogy, wouldn't you say?
Absolutely. And just like a nervous system, if the CBS goes down, the entire organism, in this case the bank, is in serious trouble. That's why historically, these systems were designed to be incredibly robust, which often led to what we call monolithic systems.
Okay, monolithic. That sounds, well, kind of intimidating.
It is a little bit. It's a way of saying that all the components of the system are tightly interconnected, almost like a giant interwoven tapestry.
Okay.
Back in the day, this made sense. You wanted everything centralized and under strict control. But it also means that any change, even a small one, can have ripple effects throughout the entire system.
Oh, wow.
Making updates incredibly risky and time-consuming.
Got it. So a bit like trying to renovate one room in a house where all the plumbing and electrical wiring are ancient and completely intertwined. One wrong move and the whole place could go dark. So this central nervous system, the CBS, what's it actually doing back there while we're out there living our lives?
At its core, a CBS automates all the essential functions a bank needs to operate.
Okay.
We're talking about managing customer information, which, as you know, has become increasingly important with all the Know Your Customer, or KYC, regulations.
Right, KYC, that's popped up everywhere lately. But what does it actually mean in the context of core banking?
Well, imagine the CBS as a massive filing cabinet, but instead of paper, it's all your digital financial history.
Yeah.
Your identity, account details, transaction records, basically everything needed to verify who you are and assess your risk profile. It's all about preventing fraud and ensuring compliance, which is critical for any financial institution.
Makes sense. Banks can't exactly operate on blind trust. So KYC is about feeding all that customer information into the CBS, making sure everything is legit.
Exactly.
Okay.
But it goes beyond just KYC. This system is also responsible for managing different types of accounts, checking, savings, loans, each with its own set of rules and regulations.
And, of course, the big one, processing transactions.
Right.
We're talking trillions of dollars flowing through these systems every day, right?
Trillions, yes. And this is where it gets really fascinating. Even a seemingly simple transaction like transferring money from one account to another involves a surprisingly complex chain of events happening behind the scenes.
Hold on. Are you telling me that sending $10 to a friend isn't just a quick click and it's done? There's more to it than meets the eye. Way more to it than meets the eye.
Let's stick with your example you want to send, like $10 to your friend.
Okay.
Seems simple enough, right?
Yeah.
But behind the scenes, the CBS is springing into action.
Okay.
First, it needs to verify your account details,
Right.
ensuring they're accurate and up to date.
Okay, that makes sense.
Then, it checks your current balance,
Okay.
making sure you actually have those $10 available.
So I don't accidentally overdraft and send my friend into a panic.
Precisely. And it doesn't stop there.
Oh, no.
The system needs to locate your friend's account, even if it's at a completely different bank.
Whoa, hold on. Different bank. How does it even find that information?
That's where things get really interesting. Banks use these sophisticated communication networks to securely share financial data. Think of it like a super secure version of the internet, specifically designed for transferring financial messages and instructions.
So there's a whole hidden network just for banks to, talk to each other.
You got it. And while all this is happening, the CBS is simultaneously scanning for any red flags that might indicate fraud.
Red flags, give me an example.
Let's say you usually only make a handful of small transactions each month.
Right.
Suddenly, you're attempting a large transfer to an international account you've never used before.
Uh-oh.
That might trigger a security alert, putting the transaction on hold until it can be reviewed.
Wow. So it's not just about moving money around.
Right.
It's about security and risk assessment at every step.
Absolutely. And if everything checks out, your identity is verified, you have the funds, and there are no suspicious activities, then, and only then, does the CBS authorize the transfer.
It's kind of mind-blowing how much is happening behind the scenes.
It is.
In the time it takes for that little loading icon to spin around on my phone.
It really is. And this is all before we even factor in the complexities of different currencies, international regulations, or the various security protocols that banks use to protect sensitive financial information.
Makes you appreciate the sheer, engineering feat of these systems.
Indeed. But there's a catch.
Oh no, what's the catch?
While impressive in their scale and complexity, many of these CBS we rely on today are built on foundations laid decades ago.
Now, that's what I was wondering about. We touched on this earlier with the whole monolithic thing.
Right.
But you mentioned some of these systems are downright ancient, older than the internet ancient.
Older than the World Wide Web, you could say. Imagine trying to run a 21st century bank on technology designed in the mid-20th century.
Sounds like a recipe for disaster.
And in many ways it is. This is where we run into the problem of legacy systems. One of the articles you shared, a piece from Backbase, makes a chilling comparison. Relying on outdated core banking technology is like driving a car straight towards a dead end.
Okay, that's a pretty stark image.
It is,
Yeah.
and it illustrates the very real dangers banks face if they cling to these outdated systems. Many banks are still using systems built on mainframes, running code written in languages like COBOL.
COBOL, that even sounds old.
It is. It was invented in the late 1950s. While it was groundbreaking for its time, it's simply not equipped to handle the demands of today's digital world.
Right.
Trying to add new features or integrate with modern technologies is like trying to fit a square peg into a round hole.
So it's like trying to cram a modern electric engine into a Model T.
Exactly. It's inefficient, incredibly risky, and ultimately unsustainable.
So why not just upgrade, rip it all out, and start fresh with something new and shiny?
You'd think it would be that simple, wouldn't you? But imagine you're living in a centuries-old house.
Okay.
The plumbing is ancient, the wiring is a fire hazard, and the foundation is starting to crumble. Sure, you could bulldoze it and build a brand new house from scratch, but that's incredibly expensive, disruptive, and there's no guarantee the new house will be perfect either. Sometimes it's safer and more practical to renovate one room at a time.
Okay, so you're saying these legacy systems are like the old house, risky to replace all at once, but banks can't just ignore them either.
Precisely. It's a concept called technical debt. The longer you wait to modernize, the more complex and costly it becomes.
Right.
And because these core banking systems are so critical to a bank's operations, there's a lot of hesitation to make any drastic changes.
So it's a catch-22. They're stuck between a rock and a hard place.
In a way, yes. But it's not a hopeless situation.
Okay, good.
This is where the concept of progressive modernization comes in.
Progressive modernization sounds promising.
It's about taking a more strategic, iterative approach.
Okay.
Instead of trying to replace the entire system in one fell swoop, banks can focus on modernizing specific areas or components over time.
So instead of gutting the entire house, you start with the kitchen, then maybe the bathroom.
Exactly. You identify the areas that are causing the biggest headaches.
Yeah.
Maybe it's slow loan approvals, a clunky online banking portal, or difficulty integrating with new fintech applications. And you prioritize those for modernization.
This sounds a lot less daunting than a complete system overhaul.
It is. And the beauty of this approach is that it allows banks to minimize disruption to their operations. They can continue serving their customers while gradually updating their core systems in the background.
So kind of like changing the tires on a car while it's still moving, but with a lot more coating and a lot less grease.
You got it. Now, you might be wondering how this all translates to you, the everyday banking customer. What does the future hold as banks navigate this modernization journey?
That's exactly what I was thinking. Will I even notice a difference? So all this talk about modernization, will I even notice a difference as like a regular banking customer?
That's the exciting part. It's not about noticing the systems themselves, but how those systems shape your experience. Imagine opening your banking app, and instead of like a generic dashboard, it greets you with personalized financial advice.
Ooh.
Maybe even anticipates, a bill payment you've forgotten about.
Okay, that would be pretty slick. But is that really possible just by upgrading the tech, behind the scenes?
It's not just about upgrading. It's about rebuilding with the user in mind.
All right.
This Backbase article argues that banks have a huge opportunity here. They've got mountains of data on customer behavior, right?
Yeah.
But their old systems can't really do much with it.
So it's like having a pantry full of ingredients, but only knowing how to make toast.
Exactly. Modernization isn't just about speed or efficiency. It's about unlocking the potential of all that data. Imagine instant loan approvals because the system can analyze your risk in real time, or getting proactive alerts to help you avoid fees.
Now that you mention it, getting stuck with an unexpected overdraft fee is the worst. Could a modernized CBS actually prevent that?
It's not far-fetched. A system that understands your spending habits could send, a nudge saying, hey, that last purchase puts you close to your limit, want to transfer some funds. It becomes less about reacting to problems and more about anticipating them.
That's a huge shift. We've been talking about how banks are playing catch up with technology, but it sounds like this could actually put them ahead of the curve in terms of customer service.
Precisely.
Yeah.
And it goes beyond just, convenience. Imagine new financial products that we can't even conceive of yet.
Wow.
All powered by this more agile, data-driven core. It could revolutionize how we save, invest, even think about money.
From COBOL to customer centricity, that's quite the journey. We've gone from the nuts and bolts of how these transactions work to this vision of a future where our banks are almost like intuitive partners.
It might sound, futuristic.
Yeah.
But the seeds are being planted today.
Yeah.
And that's the point of understanding all this. It's not just technical jargon. It has a real impact on your financial life.
So the next time I'm battling a slow banking app, it's not just about the inconvenience. It's a reminder that these systems are, evolving.
Right.
And that maybe, just maybe, we have a say in what that evolution looks like, which is really cool.
Exactly. As customers demand more, as we push for greater transparency and a better experience, banks will have to respond. The future of finance isn't preordained. It's being written right now, one line of code at a time.
What a thought-provoking way to end our deep dive. Thanks for joining me on this exploration of the hidden world of core banking. Who knew there could be so much drama behind the scenes of a simple $10 transfer?
The pleasure was all mine. Until next time.
This wraps up our NotebookLM introduction tutorial for today. I hope you enjoyed watching it and you learned something new about organizing your work and gaining valuable insights from use case documents. Please remember to like, share, and subscribe to the channel for more videos like this. Please let me know in the comments section what topics are of interest to you, and I will try to make a video for them. Thank you for watching.